Hello and welcome to Beyond the README. Today we're going to be talking about an issue that many of you have probably run into, but I bet few of you have taken the time to really take a deep dive under the hood of why this problem occurs. And that's the issue of finding duplicate IP addresses on your network when you clone virtual machines. And under the hood, this is caused by the behavior of the DHCP client ID and the way it's configured in some operating systems. So really quickly, if you want to follow along with this video, I'm using Ubuntu 2204 and I'm using a topology with 3 hosts, and I'll show you a diagram in a second. One of those hosts is a DHCP server running the Kea DHCP server from ISC, and the other 2 are just clients with basic Ubuntu installations. And this is our topology. All of these hosts are on the same network, and I've shown the MAC addresses here in this diagram in case you want to reference them, because we're going to be looking at some packet captures and really going under the hood to understand this issue. So first, a little bit of background. You'll find a number of stories online about virtual machines that were cloned and inexplicably have duplicate IP addresses. And this is especially common on recent versions of Ubuntu that use Netplan to render the network config. The typical solution you'll find is a suggestion to just adjust the Netplan configuration to set the DHCP identifier to the device's MAC address. But what's actually going on here? What's actually causing this behavior and causing these duplicate IP addresses? And we're going to take a deep packet level look at that in this video. So first, let's discuss some of the more salient points of RFC 2131, and that's the DHCP RFC. The RFC defines a number of fields, and we'll take a look at the RFC in a minute. But notably, there are 2 fields that are going to be relevant to our discussion today. One is the CHAdder, or the client hardware address, and the other is the client identifier, which is an option in DHCP. So it's not present in all DHCP packets, but this option provides an arbitrary, unique identifier for a particular client. That identifier is used by the DHCP server's database to track its clients. If the client doesn't include that option, then that hardware address, usually the MAC address, must be used instead according to the RFC. But really importantly, that identifier, because it's a key into that database, needs to be unique on a given subnet. And this is where that duplicate IP address issue lies. Because again, that identifier or that MAC address is going to be used by that DHCP server to uniquely track a client during its lifetime. So first, let's take a really quick look at that RFC. So section 2 defines the protocol summary, and obviously I'm not going to go through this entire thing and read all of it, but you can see the general packet structure here. Notably, we can see that CHAdder, and we can see down here that CHAdder is defined as the client's hardware address. The RFC also defines this new client identifier that we talked about, and that's an option to pass that explicit client ID to the server. That identifier is just an opaque key to our server. It's not supposed to interpret it, it's just supposed to use it to uniquely identify the client over the course of its lifetime. And once again, that identifier must be unique within the subnet. And so with this background in mind, let's fire up some packet captures and take a look at this behavior. So over here on the left, I've got a console to my DHCP server, and over here on the right, I've got my DHCP client 1, my DHCP client 2, and these are just VMs running in the QEMU KVM stack. So I'm going to begin by firing up my DHCP server, and with that DHCP server started, I'll just start tailing the logs. Now that I have the logs going, I'm going to come over and I'm going to power on my first DHCP client here. And that's going to start booting, and we'll take a look at the console for that device. So I've logged into the console, and I can see I've got an IP address of 192.168.100.40. I can also see a flurry of activity over here in my debug log. So let me grab these log messages and put them in a format that's a little bit easier for us to parse really quickly. Okay, so I've extracted that debug log here to a text editor to make it a little bit easier for us to look at. And we can see a message here that's advertising our lease of 192.168.100.40, and we can see the client ID right here. Now let's go ahead and fire up another VM and see what happens. Okay, so I have DHCP client 2 here, and this is just a VM that I cloned based on DHCP client 1. So I'm going to start my debug log one more time, and then I'm going to fire up that VM and we'll see what happens. Okay, with this VM up, I can see that this has also received an IP address of 192.168.100.40. So let me grab my debug logs and we'll take a look at those in another window. Okay, and now if we take a look at this debug log, we can see this message here that says we're going to allocate an existing lease to the client. And that's because this client ID here is exactly the same as the client ID from DHCP client 1. So if I come back to this log here and I look for that client ID, we can see that it matches. So this is great to see from the log's perspective, but let's also take a packet capture and take a look at the protocol on the wire to see what's going on. So I'm going to start by powering off both of my virtual machines here. And then I'm actually going to remove the database for the Kia server, and I'm going to restart it. And I'm going to fire up a packet capture. With that packet capture running, I'm going to power on my first virtual machine here, and I'll wait for that to boot fully. That's booted fully and it's obtained its IP address of 192.168.100.40. Let's go ahead and fire up the second cloned virtual machine so that we get a full end-to-end packet capture. And the second VM is booted and it's got the same IP address, so I'm going to halt my packet capture and then I'm going to grab that capture and we'll take a look at it. Okay, so I've got my packet capture open and I've filtered for DHCP traffic, and I can clearly see two distinct DHCP transactions here if we look at these transaction IDs. If we start with this first transaction and look at the discover message, and we expand the DHCP protocol section, we can see here all the different fields if you look at the RFC. Notably, we can see that client MAC address, which if you go back to the topology diagram will match the MAC address for client 1. But we can also see the option 61 for the client identifier. And the packet capture splits out the individual fields of the client identifier, but if we look at the other DHCP discover, we can see that that identifier is exactly the same, even though the client MAC address changes. And again, that might be a bit hard to catch, so let me jump back and forth between those two. We can see the only thing really changing, that client identifier is remaining the same, but the MAC addresses are changing. And so this is what causes that DHCP server to give out that identical IP address. When it receives the second DHCP discover from the second client, it looks up that client identifier in its database and thinks it's the same client as the first one. So why does this actually happen? Well, in the case of recent versions of Ubuntu, they use systemd networkd under the hood, and Netplan simply renders out the configuration for systemd networkd. One of the fields is the DHCP client identifier to use. We can see this defaults to DUID. In the case of DUID, an RFC 4361 compliant client ID is generated, and that's the combination of this IAID and DUID. And to understand where that really comes from, we have to look at the configuration file for networkd. And we can see that by default, a DUID of type vendor will be created. So that's the default DUID type to generate. And in that case, it's generated using 43793 as the vendor identifier and the hashed contents of machine ID. Now, machine ID is the file at etc machine ID. So, if we go back and we take a look at our virtual machines, let's compare the machine ID for those two machines. So I know the output's a bit small in the virtual machine console, but we have to look at the console because we have duplicate IPs here. But looking at the contents of etc machine ID on both VMs reveals that it's identical between the two. So that exact same DUID is going to be generated, and that's how we get this duplicate client ID and these duplicate DHCP IP addresses. And that's really the issue at the heart of this duplicate IP address problem. Now, there are some interesting practical implications of this behavior. So first, you may have noticed that if you run dhclient, you don't actually run into this issue. So a very common troubleshooting step that people will take when they get another VM up is they'll start running dhclient on all of the affected machines. Now, dhclient does not send a client ID, so this makes the troubleshooting a bit tricky because the DHCP server will recognize that as a unique client. Remember, without that client ID being present, the DHCP server will just use the client's MAC address as its unique identifier. As I mentioned before, the issue is typically with systemd networkd, so running dhclient will kind of point you in the wrong troubleshooting direction because dhclient is not the software that's fundamentally being used to obtain a DHCP lease. And just to really prove this out, let me fire up another packet capture and run dhclient on both of these VMs. So my packet capture running, I'm actually going to start by deleting the IP address on the interface. With that IP address gone, I'm going to go ahead and run dhclient on both of these VMs. And now let's grab this packet capture and take a look at it. Okay, so now I've got this packet capture open, and that has the packets from running dhclient, and we can see once again two distinct transactions with two distinct transaction IDs. But now if we look at this DHCP discover, we don't see a client ID option in here at all. Same thing with the DHCP discover from our other host. And this is why troubleshooting this issue can be tricky for the uninitiated. You might instinctively reach for the dhclient command, not realizing that it's not going to send a client identifier, so each host is going to get a distinct IP address. If we look at the DHCP offers for these two requests, we'll see that the IP address that's offered by the DHCP server is distinct in both cases, 41 versus 40. So we know that dhclient isn't affected by this, but when running most modern versions of Ubuntu, as I said, they're using Netplan that's rendering out a configuration for systemd networkd. And so typically you will see people suggest that you should set the DHCP identifier to MAC, and that will use the MAC address in the client ID option instead of this unique identifier based on the machine ID. And this is a relatively straightforward change to the Netplan configuration. However, this does not actually resolve the duplicate machine ID issue. Ideally, we want that machine ID to be unique on a given machine. So how do you do that? Well, there's plenty of examples of this online, but just really quickly, the Debian documentation recommends that you set etc machine ID to a 0-byte file, and this will cause it to be regenerated on boot. And they also recommend that you remove the dbus machine ID file, because dbus also relies on a unique machine ID. And those commands are shown here below. By doing this, you don't need to make any changes to your Netplan configuration. Netplan can continue to generate that unique client identifier for DHCP, but since the machine ID is different on each machine, the resulting client identifier will also be different. So thanks a lot for joining me on this episode of Beyond the README. I hope you had an opportunity to dig deeper into an issue that I bet most people have run into before. It's really easy to read the posts on Stack Overflow or Server Fault or online about how to fix the issue, but I think it's really important to go under the hood, to look at debug logs from a DHCP server, and also to look at the actual packets traversing the wire so that we develop a better understanding of what these issues are actually caused by. I think that really helps you to hone your troubleshooting skills and your abilities as an overall administrator and engineer. So if you enjoyed this episode, be sure to like it, subscribe, share it with your colleagues. I'd really appreciate it, and I'll see you on the next video. Take care.